I'm really excited about our keynote speaker. When we decided we were going to do a theme on generative artificial intelligence, I just looking around to see who would be a good keynote speaker, and I found our speaker today based on some of the really interesting presentations that he has out there on TED Talks, some singing, some music that he's done, and great sense of humor and a really expert in the field. So our keynote speaker today is a professor of computer science at Brown University. He has won all kinds of awards, and he's currently serving as the division director for information and intelligence systems at the National Science Foundation. And he has a book he just recently had published, Code to Joy: Why Everyone Should Learn a Little Programming, and that's published by MIT Press. It's available now. I just ordered a copy. Please, everyone, welcome Professor Dr. Michael Littman.
Thanks, Larry. Thanks, everybody else. It's what a great and interesting and eclectic crowd. It seems like the Trenton Computer Festival is a real kick. So it's a pleasure to be here. I don't know exactly what everybody's sort of skill and background level are, so I'm gonna start kind of basic. Hope that's okay with everybody. But I find that it actually is, even me, I've been doing this kind of stuff. I've been, I guess, in artificial intelligence for about 35 years now. And I still find it really useful to go back to the beginning and think about the concepts and how they all fit together and where they're kind of leading us to. So let's get started. So what I wanted to start off with is thinking about the sort of idea of what's cognition, what's thinking. So I think about the behavioral loop, the idea that we there we go. That let's say that you're trying to take care of tomato plants, just as a pretty random example, I guess, but you're taking care of tomato plants. That involves looking out into the world, seeing things about the tomato plants, seeing like where they are spatially, seeing how they're doing health-wise, whether they've got the right amount of water and so forth, taking that information in, applying some kind of understanding of the situation, and then acting in the world, like watering something or digging or moving leaves around, whatever it is that you have to do. And so that's something that people do. But let's say that there was an expert who knows how to take care of tomato plants, and then there's me, and I don't know how to take care of tomato plants. My head is empty when it comes to this sort of thing. What should I be thinking about? Well, I can actually talk to the expert, and the expert can tell me what I need to know, right? So the notion of teaching is about conveying information, tasks, behaviors from one person's mind into another person's mind, right? So once I get that information, then I can apply the rule, then maybe I can also take care of tomato plants. I probably will also need some practice doing it in the world myself, but that initial piece of telling me what it is that I'm trying to do is really important. So that's in the context of teaching new tasks. And what I'm going to do is I'm going to relate this to computers in just a minute. But first, I found a cute little video online. You're not going to be able to hear it because AV-wise, we couldn't figure out how to do that. But just to give you a sense of the idea of teaching, about telling somebody how to take care of tomato plants. So this is Ashley Lemon, a senior biology specialist, and she's going to tell us how to water tomato plants. So she says, all right, first you have to use the fingertip test. You stick your finger in, I think she says a 1 inch into the soil, and then you pull your finger out, and if it's dry, the tomato plant needs water. Oh, oh darn it. Sorry, more AV issues. All right, we'll try it one more time. It's a short video, so it's not too bad. Ashley Lemon, senior biology specialist, how to water your tomato plant. I guess if I just read the things on the screen, then it's not really helping you, because you can read things on the screen.
Put your microphone next to the laptop.
I don't think the laptop has any sound. I can hear the sound though. I don't know where it's coming from.
I think I heard it from the speaker. I think it's just super quiet.
Quiet?
Sure, it's a night radio.
No, don't clap yet, because we got echo. That's bad. Anyway, so she's saying, you have to water it, but make sure you get the leaves out of the way, because if you get the leaves wet, that can actually make disease, and that's a problem. And that's everything you need to know about watering tomato plants. End of ad or end of helpful video. All right. So maybe you now feel a little bit better about watering tomato plants. I don't know, but she definitely conveyed some information in there. All right, great. All right, so I want to say that there's actually, by observing Ashley Lemon, which by the way, awesome name for senior biologist, right? Fantastic. So she used a lot, in that very short clip, she actually used a lot of different mechanisms for conveying information to us so that we can take on this task for ourselves. And I like to organize these in a little 2x2 grid. So one of the things she did is she gave explicit instructions. So she said, stick your index finger about an inch down into the soil, right? It's just telling you what to do, just do this. But she's also giving examples of instructions. So she never actually says in the video that you should hold the leaves away with your full arm, but she demonstrates it, right? You actually can see her do it, and you think to yourself, oh, that's probably not a bad idea, because if you just grab one leaf and pull it away, you're probably gonna hurt the plant. You're gonna pop the leaf off. So just, use your whole arm. She doesn't say it, but you can see it. So that's an example of the kinds of instructions that she wants you to carry out. But she also conveys information through incentives. So she says explicitly, that can cause disease, right? If you overwater the tomato plant, that can cause disease. Well, that can cause disease doesn't really tell you what to do, does it? Right? There's no actual information there about your behavior, but it actually is really valuable, because that means that if you, at some point, you're taking care of your tomato plants and there's like weird growths on the leaves, you could realize, oh, that's probably what Ashley Lemon was talking about. It probably means I was overwatering. So it actually provides information that you can use to improve your behavior over time. So she tells you what you're trying to achieve. Don't make your plants diseased by overwatering, and she says that explicitly. And then there's also an example where she uses an example of an incentive by making that face. I don't know. So in the video, it's sort of here. Then still, it's not the most flattering. Still, I apologize, Ashley. But she makes a face when she says, I forget exactly what she's saying, but she's sort of saying the plant will like that a lot, right? She kind of conveys just through her own example about it feels good to the plant, right? And you can kind of see it on her face, and you can take that as a goal or as an incentive. So all these sort of 4 different crossbar-y ways of conveying information, she uses them all in the context of conveying the information to us about watering tomatoes. All right, so I relate that same 2x2, the same 4 squares, to an expression, an aphorism that William Arthur Ward wrote in the 60s, I think, in Reader's Digest. And so some of you may have seen these. Sometimes I see them on teachers' walls. It says, the mediocre teacher tells, the good teacher explains, the superior teacher demonstrates, the great teacher inspires. Right? Yeah. But it's also kind of judgy, right? Because it also, is this saying, for example, that if you ever tell anyone anything, then you're a mediocre teacher? Like, no, right? No, good teachers tell you things too. Great teachers tell you things too. It's just that the great teacher does all of these things, right? And so, but it's really interesting to me that they hit on these in all 4 of these cells. The notion of telling, giving explicit instructions, explaining, explicitly saying what your objective is, what you're trying to achieve, demonstrating, in other words, giving examples of the kinds of things you want done, and inspiring, right? Showing through your own behavior, your own attitude towards the problem, what it is that you're trying to achieve. All 4 of these work together. All right, so this is all in the human domain, but let's kind of think about this in the context of machines as well. So if we're trying to convey a task to a computer, and by the way, I think that's what computers are for, right? Sometimes we forget, people tell stories about how, oh, I don't know, computers are taking our jobs, or computers are dehumanizing us. Like, that's not really what computers are. Computers are tools that we can tell what to do. And the more it is that we outsource this, the more that we say, oh, well, that's hard, we'll just let these big corporations do it, the more the big corporations or even small corporations are going to use that for their own ends, right? So I think it's really important that all of us take as a responsibility the role, or take very seriously the role of telling machines what to do, because that's how we can influence the behavior to be the behavior that we actually want, and not that someone wants on our behalf. All right, but so from that perspective, this notion of conveying a task is exactly what we're trying to do with computers. That's what we refer to sometimes as programming or coding. It's about telling the machine what to do. And you get the same kind of setup as the behavioral loop that I was explaining earlier, that we, the knowledgeable person who knows what we want done, is going to somehow convey to the computer about how it's going to interact with the world to get done the task that we want done. And again, the computer can take in information, like if it's going to be watering plants, it can take in information about recent rainfall, whether or not it has, spritzed the plants recently, what the current temperature is, or what the temperature has been historically, the height of the tomato plant, how red it is. Like there's things that computers can pretty easily sense about the world, and then maybe some actions that they can take as well, like spray the plants, like put some water in the plants, or don't put some water in the plants. All right, so yeah, programming is not so different from telling people what to do, and we also have those same 4 boxes available to us when we're telling machines what to do. So we can tell, which is what we think of as traditional programming. We give explicit instructions to the machine. Do this step, do this step, do this step, do this step. We can also explain. This is an area of machine learning called reinforcement learning, or sometimes planning, where we actually just write down what we want accomplished, and we let the machine work out the details of how to accomplish that. So as long as it can sense the right information for being able to take actions, and as long as it can sense the things that are relevant in our explanation of what the objective is, we can actually outsource, in a sense, the programming to the machine. And that's the field of reinforcement learning, which is sort of my home research field. That's what that area is concerned with. The notion of demonstrating is actually really important in telling machines what to do as well, in the context of what's called supervised learning, where we give a big data set that says, if you see this sort of thing, do this in response. If you see this sort of thing, do this in response. Thousands and thousands, tens of thousands, millions of examples potentially, but then the machine can actually extract from that a way to copy that behavior. And then finally, and I'm going to talk about all of these, but inspiring is kind of the least well worked out one at the moment, but you can actually learn objectives by watching the behavior of others. So you can give the system data, and the system can infer from that what it is that you're trying to do, and then take that objective as its own objective and act on it. All right, so that's kind of the map of the talk. I want to fill in these 4 boxes for you and talk about how these are done today and how you can engage with them. All right, so so first, traditional programming, or sometimes coding. So the idea here is that we're going to give the computer explicit instructions for what actions to take in what circumstances. And one of the powerful things that we have for doing that is the notion of control flow. So we don't just write out as a script, like do this step, do this step, do this step for every possible step. We can actually write meta instructions. So, and I'm sure a chunk of the folks here have engaged in programming, so you know what I'm talking about. If you haven't, there's information that you can give the computer about what steps to take, but also how to sequence those steps. So, for example, you might say, spray. If you want to express to the machine, I want you to spray the plant every other day. So I might say, spray today. So today, spray. Let a day go by. Next day, don't spray. Let a day go by. And then repeat that forever, right? That would be every other day, water the plant. Every other day, don't water the plant. So that forever is an example of a control flow statement. Right? It's actually telling the machine how to interpret or how to sequence the instructions that we're actually giving it. Where spray today and delay watering are the actual instructions that can be executed in the world. All right, here's another one. So maybe somebody can tell me what you think this is saying. If you're familiar with the idea of coding or you've been following so far.
It's an event-based.
It's event-based. All right, but how would you turn it into English? How would you express this idea?
If there is no rainfall, water the plant on that day.
Okay, is that you were thinking too?
I was gonna say, like, if there's no rainfall, it should spray.
If there's no rainfall, then it should spray. Yeah, okay. And otherwise you just skip that day. Yeah, right. So essentially, it's like I'm going to water the plants on every day that it doesn't rain. Or at this hour, okay. Not spray over. Oh, unless you spray. I didn't catch that. But in the if statement there, it says if not the case that there's rainfall, or we sprayed on the previous day, then we don't. Then we're gonna withhold the spray. So it'll spray on if the previous day was dry. If it didn't rain and I didn't spray, then I should spray. All right. So again, it is kind of like the previous one that we're going to spray every other day. But if nature does the spraying for us, then we can actually save the water. All right. So this now uses 3 control flow statements: the forever, the if, the else, and also the logic in the not and the or. Right. So you can start to build up in sophistication the kind of logic that you want the machine to follow.
Whereas yesterday,
Yeah, it was sort of implicit in the statement. Yeah, I didn't give you all the information you actually needed to answer that. I apologize. All right, so here's a more sophisticated example that I'm not going to go through in detail. And so this notion of being able to give commands actually has many different forms. Usually it's a textual thing. Most programs today we write out as almost like a language, like a human language. And there's many different computer languages that have been developed. I just tried to alphabetize them, and then I got bored. Algol, Basic, C++, Python, R, Scala. There's at least one language for every letter of the alphabet. Some letters have a lot. But then some computer languages, instead of being all completely typed text, they can be, shapes that you click together, like the programming language Scratch, which I'm a big fan of. So this is like a rainfall example from the perspective of written as a Scratch program where you can click blocks together, but really it's the same thing. Under the hood, it's still just textual commands. But you can have other kinds of GUI interfaces or user-friendly schemes like trigger action programming, also known as if, where you're given a set of possible triggers and a set of possible actions to take, and you just have to say, if this trigger happens, then do this action. Very simple, surprisingly powerful, but not as powerful as full programming. And so, okay, so great, then we have a way of telling machines what to do. We could probably be done now, except for people, right? It turns out that it's actually hard for people to pick up these kinds of skills, to learn how to program in this form. And so one of the pieces of evidence for this I find really interesting. So back in the 80s, when I was a college student, they tested a bunch of college students at that time who were taking programming classes. Like, I think I just missed by like a year the possibility of being one of the experimental subjects in this experiment. And I'm glad, because this experimental subjects did not look good. So they were asked, so students took at a highfalutin elite college, they took a programming class, and at the end of the class, they were asked, hey, write a program in Pascal, that was the language of the day, write a program to compute the average of a list of numbers where the list is terminated by just the number 99999. So just there's one special number, that number signals that the list is over, and then, okay, compute the average. 86% of the beginning students could not write that program corresponding to that really simple concept. They knew how to do averages, they knew how they could do it by hand, they just couldn't write code to actually do that. And so this was back in the 80s. Decades went by with computer science education people wringing their hands saying, like, what are we doing wrong here? How can we get through to these people? and it remains sort of an interesting problem. How do we teach people to program? It is not trivial. Obviously, lots of people learn it, but it's work. It is really difficult. So, and it's not just the beginning students who have trouble. Professional developers have created bugs that have crashed spacecraft, cars, power grids, the internet, like anything you can crash, somebody's written a program that has crashed it. Where the goal wasn't to crash it, the goal was to actually help, but the bug made it all go downhill. So that's unfortunate. And so I kind of waded into this with my own research a little bit, because I thought this trigger action programming was like a really cool idea. Maybe this is the way. This is finally how we're going to teach people to program. And so, so we asked people to do a bunch of tasks. We recruited people, I guess mostly off the internet, and asked them to write a trigger action program that does the following thing. And it turned out that 60% of the users, nearly 90% of the people could write the programs that we asked them to write. But then in a follow-up study that we didn't do, another group said, that went too well. So they actually did a study where they said, here's the program, what does this program do? And people were like, oh, I don't know, right? So they could write it, but they couldn't read it. And that means that they didn't really understand it. So that they got kind of lucky. They were able to write a program that did the right thing, but they didn't understand why it did the right thing. And in particular, they had a difficult time interpreting conjunctions or ands, where we would say, do this, if such and such is true and such is true, do this. All right, which seems really simple, but people wanted to interpret it a very specific way that wasn't the way that the programming language actually worked. And no matter how well we read, we tried many times to reword it. Oh no, this is totally going to work. Still, a huge chunk of the people, about 2/3 of the people, just wouldn't interpret it the way that we wanted them to interpret it. So even trigger action programs can be actually quite tricky for people. All right, so maybe the problem is programming. Like maybe we should move away from programming. We've got 3 other boxes in our 2x2 grid that could be the way that we tell machines what to do. So let's focus in on reinforcement learning. So let me tell you a little bit about what that is. So given that computers are so powerful and instructions can be limiting, it can be hard sometimes to know what to say and how to say it. Well, maybe if we tell the computer what we want it to accomplish, that might be less buggy, right? Because people know what it is that they want. right? Sometimes. And so the computer can use its power to kind of work out the details behind the scenes. That didn't make sense in the 80s, but it surely makes sense now. Computers are tens of thousands of times more powerful than they were then. And so we can use that extra power to just make life easier for people. So the goal is you tell the machine how it should evaluate its answer, it will come up with the answer to fit that evaluation. All right, and so the key idea here is that you need to be able to express the objectives, what it is you want the machine to do. So there's been some success in using this kind of approach to solve some really hard programming problems. So the computer games and board games have been a really rich source of interesting problems to solve using this technique. So Go, chess, shogi, these were all mastered by a program out of Google DeepMind called AlphaStar, which used the reinforcement learning approach, where you said, oh, well, I know what it means to win in Go. I know what it means to win in chess. I just don't know how to tell the computer how to make the best move. I was okay, well, let's just tell the computer what it means to win and let it figure out the best move. And that actually turns out to be incredibly powerful, to the point where for the games of Go, chess, and shogi, the computer programs built this way have beaten the best human beings ever to play the game. And people have actually learned a tremendous amount from the strategies that these programs exhibit about how to play these games better. So people are getting better by watching these programs that got better. So that's really neat. I like those games, but I also like 1980s video games, Atari video games. And so I was really excited to see that, this same DeepMind group picked up on the idea of, well, maybe we can actually program computers to play video games. And so, let's see, so you can actually see them a little animated here. So these are all videos of the computer playing these video games, where it's given as input a picture of the screen, like the actual frames of the screen, and its output are just sort of joystick commands. And what its objective is to maximize points. It's told when it's scoring points in the game, and it just kind of flails around until it figures out, oh, this kind of behavior seems to lead to more points. So they don't even tell the computer what to do other than to say, you should be maximizing points, good luck. And for a bunch of these games, averaged over a set of about 50 games, it actually was doing better than an expert person who was new to these games, an expert in playing video games, but who was new to these particular games. And on some of the games, just crushed the best people, because the lightning fast reflexes sometimes really pay off. But then there's other games where it actually did really poorly, more like planning kind of adventure games where you have to wander through a world, remember what you've seen, and remember what to do. These kinds of more reflex agents are not as good at those kinds of games, or haven't been so far. But still pretty remarkable that you could actually, it would be hard to tell a computer, here's the right move to take when the screen looks like this. That's a very difficult program to write. But it actually can figure it out on its own using this reinforcement learning approach. All right. So we can apply this in the context of, obviously, the most important problem in the world, which is taking care of tomato plants. Or at least it's the theme in this talk. So a program for using reinforcement learning to take care of tomato plants might look something like this. We tell it, forever, like on every step, every day, you should be making a decision. You should use whatever information you have in the rainfall, the temperature, whether it's spraying yesterday, happened, the height of the water, the tomato plant, to choose either spray today or delay watering. And the important thing is maximizing height. We have to give it explicitly what the objective is. You can't just tell it, be good, right? You have to say, be good, and here's how you measure how you're doing, right? Because it's going to experiment with the world to try to figure out which things bring about the desired objective. And that objective has to be measurable to the computer, right? If it can't see whether it's doing well, it can't change its behavior to do better. So that's how you might write a reinforcement learning program to solve this. Now, how would this actually work in practice? You would kill a lot of tomato plants, right? Because in the process of learning how to take care of tomato plants, what's the expression? Like, you have to kill a few tomato plants to learn how to know. You have to break a few omelets you have to eat a lot of eggs. Anyway, there's an expression. The point is that through experimentation, it's going to have to learn how to use the right action at the right time. And since the space of possibilities there is enormous, it might actually take, with no additional information, it could potentially take a very, very long time. Now, if you've got tens of that, so you're not just taking care of tomato plants yourself, you've got an entire farm of tomato plants. Each tomato plant has its own little controller connected to it. It could probably do those experiments, and it could probably learn pretty well. one of the reasons we're seeing an explosion in the application of machine learning ideas, which machine learning dates back to the 50s, right? So people have been doing using these kinds of ideas. Why are we hearing so much more about it now? The answer is, we now live so much of our lives online that lots of data about what we do and how we do it is captured, and therefore can be sent to these computer programs so that they can learn how to do things themselves, right? So the opportunities now to learn from experimentation are much greater. And so that's why, even though here you probably have to kill a lot of tomato plants, this is why big companies are actually doing things like, which ad should, Netflix is deciding, which picture should we show you this video to make you want to watch it? Because the more you watch it, the more you stay on the service, the more you stay subscribed, the more money they get. They actually do these kinds of reinforcement learning experiments. They say, here's a bunch of pictures that we can show people that advertise the, I don't know, Love Actually, I think was one that I've seen talked about, where they had a bunch of different stills from the movie. People know Love Actually, right? It's like a Christmassy kind of feel-good movie. And it turns out that different kind of people are more likely to watch the movie depending on which ads you show them, which pictures from that you show them. Like young people want to see, you know, sort of cute young people interacting. You know, older, more mature, more seasoned individuals might want to see the older characters interacting. Whatever it is, the point is that the Netflix people didn't know how to decide who they would show what thing to. So they just said, here's a bunch of pictures, here's a bunch of facts about each of the people who are using the service. You decide what picture to show what person to maximize the likelihood that they're actually going to watch the movie, right? That data is measurable to the system. It can actually, in its database, it knows, did they watch Love Actually, yes or no? Here's the picture we showed them, here's some attributes about that person, here's whether or not they actually watched the movie. Big data set like that, which Netflix has, because there's lots of people interacting with the site, they're able to actually figure out which thing to show you in particular. And it's incredibly effective.
YouTube does something similar with its thumbnails. I think creators can choose a subset of different thumbnails.
Oh, I didn't know that. So they give the action set, as it were, to the individual creators of a YouTube video, and they say, you know, show them one of these things to make it more likely that they click on my video, and then behind the scenes, YouTube will actually do that experimentation.
But the thing is, they show you a picture that is not in the video.
You can choose a image that may not be in the video if you
Yeah.
like. That's
So-
all we were.
So, okay, so a thing that I think we're kind of edging up to the side of that we probably should mention is that these are really powerful technologies that can be abused, right? They can actually mislead people. They can get people to do things that aren't in their best interest. This is a real concern. We have to be very careful about this. Yeah.
We also have in the news mostly wars and crime. We have horror movies being really up there. What are we teaching our computers?
Right, so if we build computer programs by having them watch what we do, that may not be the best way to move forward. I mean, like, you know, when we raise children, we don't show them all of our strange adult behaviors. We kind of choose how to present reality to them so that with the hope that they're actually going to grow into people that are at least as good as us, hopefully better than us. So, yeah, no, really good point. Thank you for saying that. All right, so, yeah, so I mentioned chess, and we talked about machine learning. One of the ways that reinforcement learning can be abused is what we're hearing about, the idea that it can be used to manipulate people based on learning trends across different people's demographic information. But here's another kind of really interesting, wacky one that people are very concerned about. So this is an example of, let's just have it play a video game, and nothing bad is going to happen to any real people. So don't fret. But it's kind of an interesting example. So in this video game, you control the white speedboat. You're trying to go around the track and be faster than all the other boats. And again, from a reinforcement learning perspective, it gets to see the screen, it gets to control the acceleration and the direction of the boat, and it's told maximize points. That's the points are available in the game. Figure out how to behave to maximize this. And so it plays, I don't know, hundreds of years of this video game. Like, again, it's not having a good life, but it lives a life in this video game. And the interesting thing about it is it actually learns to gather points extremely effectively. So let me show you what it looks like, what the learn strategy actually looks like. I think it might be on a different slide. Here we go. All right, so this is what it actually learns to do. There's our white boat. It's shooting ahead of the competition. It is going backwards on the track, which seems like a weird choice. And it's smashing into a lot of things, which is maybe not what you'd expect. But now it gets into this harbor zone, and it's running into those green explosion things. You see them on the bottom there, boom, boom, boom. Those actually are worth tremendous amount of points. So it has figured out a way to smash into the wall so that it's in place to get all those points, and then they reset, and it's right back there to do it again. So it figured out the tightest way of getting points, maximizing the amount of points per second. It's just chewing up all the points. And people are like, is that good? Because it seems like it's running into a lot of walls. And if we actually field self-driving cars to maximize points, this is not what we want them to be doing. It's like, yes, whatever. You give it the objective function from Grand Theft Auto, and then all heck breaks loose. Like, this is not great. So what happened in this case is the reinforcement learner was actually quite effective at maximizing the objective it was given. But the objective it was given wasn't exactly the objective that we wanted it to maximize. We wanted it to play the game, but it turns out that points were only a weak proxy for winning the game. And that happens all the time. Like some of the YouTube stuff that we have seen, like YouTube will often present videos to people in a way that actually gets them to become more extreme, that keeps them on the site. It creates all kinds of kind of negative feedback loops where people get kind of a little bit addicted to the site. I don't think, I mean, I know some of these folks who built these systems, that wasn't what they were trying to do. They were just like, oh, well, one measure of whether they're enjoying what they're seeing is if they keep watching. So, okay, but then what the system learns to do is to get people to keep watching, even if it's not necessarily in their best interest, right? Because measuring their best interest isn't something that they had direct access to. So we have to be really careful when we pick these objective functions that we're actually expressing something close to what we actually want achieved. All right, so okay, I should have kept time someplace. There isn't a place for that. Do you know how I'm doing there?
Well, it's 4:22.
All right, and when am I stopping? 2 minutes from now.
Whenever you're tired.
Oh, that's not good for anyone. See, that's an objective function that if we optimize it, it's not going to be good for anyone. All right, so let me just move on to a couple more examples, and then hopefully we'll have some time for discussion.
The analogy I got from it also just now is the getting wishes from the devil. You know, you
Yeah.
wish for something and
Another analogy, yeah, that's a good one. Another one that people sometimes talk about is the genie example, where there's a lot of stories where a genie says, I will grant you any wish you want, and then you say what you want, and the genie manages to misinterpret it, like stick to the letter of what you said. I want peace on earth, and then the genie kills everybody. Like, ta-da, peace on earth. That's not what I want. So, yeah, I mean, sorry, killing all people on earth wasn't intended to be a laugh line, but nonetheless, the idea is exactly this idea, right? That you get this dissociation between what you said and what you actually want. All right, let me talk a little bit about supervised learning, because the theme here is generative AI. A lot of that is actually built on top of this idea of supervised learning. So here is where we're trying to get the system to actually learn from data. So in the context of, again, we're going to go back to tomato plants. If we watched Ashley Lemon for a whole lot of days, 3 years, let's say, 1,000 days, we might be able to record things like, oh, so one day there was rainfall, the previous day she didn't spray, the previous day the temperature was high, the tomato plant was short, and her action was to delay, not to spray that day. But then another day, it hadn't rained, there was no spray, the temperature was low, the height of the tomato plant was short, but there she did spray. So we have lots of examples of that, of what she saw and what she did. And now what we want is the computer to figure out a rule that actually acts like Ashley's rule, right? But maybe generalizes to cases that weren't demonstrated in the data, right? If Ashley actually says for all possible values of the inputs what to do, then she's written the program. That's actually really easy. But what's interesting is you can get a lot of mileage out of just giving a handful of examples, well, thousands, big hands, and from that infer, like kind of read between the lines as to what the rule should be in cases that weren't observed. So this turns out to be remarkably powerful, especially if you've got enough data, and can solve some problems that people had been grappling with for decades that are now actually fairly well solved. Spam filtering, face and image recognition, speech recognition. The fact that we can talk to our phones now and it basically understands the words that we said is because behind the scenes, a giant machine learning model was trained up with lots of examples of people talking and what the words were, and it's able to glue all that together and actually very accurately figure out which words are being said. Which again, this was a problem for, again, since about the 1950s, people were trying to write programs to do that. Could kind of do it, it would only recognize digits, but that can be useful. the fact that we can now do general, like you walk up to it, it's never seen you before, it's never heard you before, you can say just about anything you want and it'll type it out, that's remarkable, and that's due to these machine learning, these supervised learning algorithms. Being able to recognize lots of things in images, that's, again, a problem that people didn't know how to solve. Machine learning was finally able to crack it. Automatic language translation, discovering cats in YouTube videos. There's all sorts of things have been solved. So the thing though to realize, let's see. Oh, okay, I had a better picture of this, but I didn't include it in the talk, sorry. So one of the ways that this kind of example-based programming, the supervised machine learning systems can go wrong is if there's information in the data that's sort of biased in some direction, it's going to maybe pick up on a shortcut that isn't always true. So the classic example that people like to talk about in the field are you want to train something to distinguish husky dogs from wolves, which is definitely a thing that I've struggled with. They look very similar to me. That is a husky dog. But the program that was actually trained to distinguish husky dogs and wolves, which was highly accurate, thought it was a wolf. Why did it think it was a wolf? Because there's snow in the picture. So it turned out that it's much more likely if you see an animal that looks like that and there's snow behind it, it's probably a wolf. It picks up on those statistics and generates a rule that says, I don't even have to think very hard. If there's snow, it's very likely a wolf. But then you give it these examples that are kind of off the data that it was trained on, and it makes big mistakes because it didn't learn the thing we actually wanted it to learn. It just learned how to be accurate on the training data. So this is actually being used to create what are now called large language models. And the way that these large language models are trained is by having them predict the next word in a word sequence. So the context, the inputs are the words leading up to a word, and then the correct answer, what it's supposed to produce, is the word that would come next. So we can use supervised, guess the next word, it should be machine. Can use supervised machine, the next word should be learning, right? Again, billions of examples are presented from text that comes from all different corners of the internet, and you can build up a machine learning algorithm that is very accurate at actually predicting what the next word is. That's a super useful task for things like speech recognition, right? So if you know what to expect the next word, or how likely different things are and how unlikely other things are, then when you sort of hear the word okay, you can still be fairly accurate at predicting its identity because it makes sense in context. Right, so being able to capture that context and bias things in that direction, extremely valuable for being able to understand speech. But what's really shocking is these same models, once they were trained up and were sufficiently accurate, they could do all sorts of other weird things. Like they could write stories. You just kind of get them started, let it predict the next word. Like, what do you think would come next in the story? It picks a word, and then you say, oh, what do you think would come after that? And it picks a word. Word after word after word. It actually is incredibly coherent. Right? If we train these models up on enough data and they're powerful enough models, they can actually write. They can translate. You can say, oh, I met a friend on the street and he was speaking Spanish. I think, and here's what he said, and then you write it out in Spanish. But what that is in English is, and you just let it fill in the rest, it'll fill in the translation in English. Right? Because that's sort of the natural thing that would follow that. If you've seen enough text, that's the right answer. It can have conversations, right? You can kind of go back and forth. I'll say something, it'll say something back. It can answer questions. It can solve some very basic kinds of problems. It can take direction. You can kind of give it instructions, tell it what to do, and it can follow them. And it can even write programs. You can say, oh, the other day I wrote a program to average a list of numbers, and it started out like this. And then it goes and it fills in the rest of it, and it's a correct program for averaging a list of numbers. Right? So that's actually really surprising. This, of course, is something that everybody probably recognizes as whatever it is that ChatGPT does, right? This is how ChatGPT was created. They started off just training it to predict the next word on a huge corpus of text scraped off the web. And once it was actually good enough at that task, it can now do all these other tasks kind of for free. So I decided, since I was interested in this rainfall problem, what if I actually said that? I say, right, and okay, so there's another step that I didn't talk about here. They also train these models specifically to follow instructions using supervised learning. And then they also train it to give good answers using reinforcement learning. So they hit kind of a supervised learning, a different supervised learning, and then a reinforcement learning to create what we now see as chatbots in the world. And so I was able to say to it, write a Python program to compute the compute average of a list. I'd left that the average of a list of numbers terminated by 99999, and it said you could write a Python program that reads numbers from the user, adds them to a list, and calculates the average of the numbers in the list. This is now the program that's spinning this out. The program should stop reading numbers when the user enters the sentinel value. I didn't use that word, but that is the technical term for that magic number, 99999. Here's an example implementation, and then there's a Python program that runs. Kind of amazing, right? So people didn't actually set out. The idea of automatic programming had been on people's radar for many, many years. They didn't set out to create an automatic programming system that you can describe a program and get a program as output, but they got it for free from this kind of this supervised language model, this generative model. Really remarkable. Now, it turns out there's one bug in here.
Just one.
Yeah, one that I was able to identify. And so it's arguably not a bug, but it is like a feature that is unintended. Right here. It says it inputs the num, and then it says num equals int num. Does anybody know what that would do?
Yes.
It's casting. All right, so it's taking whatever number is typed in and it rounds it to an integer, maybe truncates it to an integer. It turns it into a whole number. I didn't tell it to do that. I don't think I wanted it to do that. If you give me a fractional number, you should just average in the fractional number. But it chose on my behalf to turn that into an integer and then average all the integers together. So that's arguably a bug, or arguably a feature that I didn't ask for, which sounds like a bug. If I were a non-expert programmer, and I was like, oh my gosh, this is so great, I can program in English now. I describe the thing in English, it spits out the program. How am I supposed to know that it's not the program that I wanted, right? These systems are amazing. But at the same time, they don't take somebody who can't program at all and make them be able to write correct programs. Really good at helping them write incorrect programs, right? That it can do in a heartbeat. But if it's the program that they actually intended, it may not actually work out that way. So I think that's super interesting. And it's worth keeping in mind that one of my colleague, Charles Isbell, who's the provost at the University of Wisconsin now, he likes to say it as, these systems let you be an editor, but you can't be a good editor until you're a good writer. And so these are not substitutes for people learning to code. Not yet, anyway. So, but I just think this is so conceptually weird and so cool that we want a program that predicts the next word. We don't know how to write that program, so we use machine learning to write that program. But the resulting program that came from that itself can write programs, translating descriptions into code. So, kind of awesome. All right. All right, I'm not going to dive into this, but there are some examples of trying to extract objective functions from behavior. They have been used to do things like create artificial photographs. So that's a photograph of a woman, but that's not an actual person. It's just generated by a computer program where it learned from looking at real pictures of people what things that you need to include in a picture of a person so that it looks like a person, and it learned it really well. You can go to, if you want to play with this, you can go to thispersonsnotexist.com.
It wouldn't pull like a stock photo and then put background?
No, I mean, so people have caught it. People have actually found themselves being output as a fake person, but it's hard to know. Like, is that person really in the database? I'm willing to believe not, but it's also possible that it is, and with a different background or maybe added glasses.
Like the commercial you see where it says like, have a person on a cloud reading a book. You know, the person, I don't know if you've seen that commercial, but it's for, I think, Deep Blue or something, their AI. I'm thinking that person is a stock person.
Right.
The cloud is.
And it's sort of assembling these pieces together.
Right.
It's difficult to tell. At some level, it's definitely assembling pieces, right? Because it doesn't know what hair is. It only knows the hair that it's seen. And so something about her hair is definitely in the database. But whether it's the whole ensemble is in the database or not, it's hard to tell. They're trained on millions of images, and no individual human being has looked at enough of them to be able to answer that question. Yeah.
To expand on that, I think part of it is if it got to a almost perfect replication of a real human based on an image and its training data, just by chance, I mean, that can happen. It's by chance.
Well, no, but sometimes, no, right. So it could just hit on there's something like 11 dimensions that we think people are paying attention to when they're recognizing faces and distinguishing them. It could be that it lucks into the same thing. But there was an example that I saw where it was a woman's like, I don't know, it was like a TikTok or something, it's like she was like, oh my gosh, that's me, and then there was the picture and it was definitely her. And so sometimes it does spit out real people, but we don't know, like in their databases, it was trained with real people, it understands the real people, it can assemble pieces, but sometimes it can assemble a whole person that it's actually seen before. This is an issue with generative AI with text as well. You can sometimes prompt them in such a way that it starts to spit out actual text that was trained on, like a book that's copyrighted. And the people who have those copyrights are now starting to sue the AI companies, saying, we didn't say you could do that. We didn't say you could make a program that would actually spit out our book, because this is our book. We own that. And so, what's that?
Or learn from the book.
It can, well, you're right, with art, yes, but certainly, I think it's a much brighter line to say, you can't just output their book. And so this is all playing out in the courts now, and another reason that we should all be kind of paying attention to these issues, because it has an effect on how society is gonna run. All right, so that was kind of my story, talking about these 4 different boxes. And oh, and then the talk ended. Thank you. All right, I definitely want to give people a chance to ask questions if that's still allowed. Yeah, please.
And there'll be time
Oh.
after the microphone, around the banquet hall.
Oh.
Everybody, the various speakers come up with you can.
Oh, great. Okay.
answer questions.
All right, so there'll be an opportunity then, but can I take a question now? Is that okay?
Absolutely.
Okay, fantastic. Yeah, go ahead.
So as I was exploring some of the alternative LLMs, I started hearing about and reading about courses on prompt engineering.
Yeah,
And
yes,
prompt
prompt
engineering is a programming language,
Yes.
if you will, to tell a generative language model how to do what you want it to do. So, I mean,
Yeah.
we're getting more and more meta as we go from machine language to assembly to high-level languages, and now a language to tell the machine what to do.
Yeah, so this is a really good point. And so when I hear people say things like, oh, we don't need to teach coding anymore because these programs are so good at writing code, it's really interesting because you still have to kind of be a code whisperer, right? You have to kind of coax them to do the right thing, which is itself a form of programming, right? I think some of us have experienced this, even as simple as interface as with Google. I don't know if probably a lot of folks here are really expert like Googlers, right? You can actually type in a query and get the thing you want, and you sometimes watch other people do it. You're like, no, don't type that. That's not going to work, right? We can internalize a sort of a rhythm of what the queries are going to be effective at, and this is also true in terms of what you're referring to as prompt engineering. This sort of notion that these large language models, or LLMs, which is my initial backwards, MLM, no relation. So so you have to get them to solve various kinds of problems, and so you have to express in words what it is that you want them to do, and those are called prompts, because really, again, it's just filling in. You give it, you set up the situation, and then it kind of continues the flow after that. So you prompt it, and then it fills in. And then finding the right prompt to do just the thing you want can be subtle. So I tried to get a language model to name the color. I wanted to know how much it knew about colors, which is, I thought it was interesting because they can't see, right? These language models are trained on text. They just read things, people talking about colors. They don't see colors. So I wanted to know, like, what color is Grimace? You guys know Grimace? It was a character from McDonald's. All right. What color is coal? Right? What color is a tuxedo? So I had this list. I made a list of 100 questions like that. And by varying the prompt, varying the way that I explained to the computer what I wanted it to do, it was better or worse at this. So if I just said the color of snow is, and I just let it fill in the word, it would get white, so that's great. I would say the color of a pencil is, and it would say not important because it's actually the lead that matters. I'm like, okay, you're right, but not what I was going for. So it turns out you can actually modify the prompt. So you say the color of snow is white, the color of blood is red, the color of the sky at night is black, the color of a pencil is, and it says yellow. So by setting it, by giving it the right context, you can actually coax out of it the sort of things you want. And that's what people refer to as prompt engineering. That's a skill, right? And people who can do that effectively can get more things out of these models better. And so will that become like the job of the future? This is a question that a lot of people have. I don't know the answer yet. I don't know that a lot of people are being hired as prompt engineers at this time. But people are sort of hopeful, right? To the extent that it's going to take away programming jobs, or maybe writing, stock text jobs, it would be nice if we had something else to do. So maybe prompt engineering, but I don't know. It's super interesting. Yeah, in the hat.
If I wanted to go home and do some, reinforcement learning on a video game that you had done, like,
Yeah.
what tools would I use to do that?
That's a really interesting question. So one of the things that's really remarkable about this moment in history is that, well, so, okay, when I was learning to program, I had a magazine, like I had subscribed to a magazine, it was called Creative Computing, I think. And you could flip through it and sometimes there'd be programs written out in text that I could then type into my computer and then run. We're in a better world now where not only do you not have to type it because you could just download it from someplace, but there's all these tutorials and videos and interactive websites and libraries, right? Actual code that you can build on top of. And so there are a bunch of, I mean, what I would do in that particular case is I would download the Atari playing program that I talked about. It's called DQ Network or DQN. The code for that, a bunch of people have written it and posted it online. You can download one of those, and then you just have to write the code to take your video game screen and your video game controller. Like you have to write that glue because they won't tell you how to do that. But in Python, you can ask the language model. You're like, oh, I've got this kind of thing and this kind of thing. Write me code to do such and such. It's actually really good at that. So you can glue those things together, and then you can run the program. One of the things you'll discover is it's not as straight out of the box as you might think. The first time you run it, it's going to be terrible, because it's going to either learn too fast or too slow, or pay attention to the wrong things, or be overwhelmed by the details. So you'll have to do things again to coax it to get the behavior that you want. But what's great is all those tools are out there, and you can actually experiment with them. Yeah, yeah, go ahead.
Yes, Google, AI for images.
Yes, Google AI for
really
images.
screwed up because if you say, give me a picture of George Washington, he comes out as a black man. So why do they want to screw around like that?
All right, so the question is, this is with regard to the language model that was recently released from Google called Gemini, thank you. So that's right, yeah, it's pedagogically, I just wanted you guys to give the answer. It wasn't that I forgot the word. So Gemini, so when ChatGPT was released and some of the language models that came before it, they got a lot of criticism because these things are trained up on the internet. Turns out the internet has a lot of garbage in it, right? And so it would actually echo a lot of like racist stuff and incorrect stuff like conspiracy theories and so forth. You can very easily coax them without even trying to spit out really toxic text. And so the Google engineers, when they were going to put up their web engine, they were like, we don't want that to happen. We're going to bend over backwards to make sure that we get representative images and representative text. And then weird things started to happen where you ask for George Washington, and it's like George Washington of color, right? And I think they were trying to do the right thing, but I think they may have overcorrected. And it's not clear how to fix this. It's not clear how to make it so that the system is biased when, or accurate when it should be accurate, and more generic when it is appropriate to do that way, because doing that exactly right requires human level intelligence. And these systems, as amazing as they are not actually human level intelligent. They don't understand the subtleties of our culture. They don't understand all the subtleties of our language. And so they're going to be wrong for a while. It's just, yeah. And so I think we as a society have to decide, well, who are we going to hate on? Which companies are we going to hate on? The ones that are kind of too much leaning into diversity, or the ones that are too little leaning into diversity? Should they just output whatever they output and just like not accept any criticism? I don't know the answer. I don't know what's going to encourage the best behavior, but that's something that we all have to be thinking about.
Well, couldn't they use machine learning to millions of pictures that are out there of George Washington?
That's what they did.
Put that in the machine.
That's what they did.
When you say draw a picture of, give me an image of George Washington,
Yeah.
could use machine learning.
Yeah. No, you're absolutely right. But the issue is, so again, the question, just in case people can't hear, the question is, well, couldn't they just train it on lots of pictures of George Washington? That's 100% exactly what they did. The thing is that when you just do that, and then you say, give me a picture of a doctor, it's going to give you an old white guy. And nothing against old white guys. Some of my best knees are old white guys. But the point is that you want it to have a more inclusive concept of what it means to be a doctor than that. And so it's trying to correct that problem that messed up the George Washington issue. You see that? And because people aren't writing these programs, they're just training them. There's no way to actually have that level of control of saying, well, when it's an actual historical figure, use the historical figures features. And when it's not, when it's a more generic concept, there's no place in the program that you can point to that does that calculation. And so they don't know where to fix it. You can't debug that. All you can do is try to give it better data, but that's the tricky thing about machine learning, since you're not actually instructing it. You're not telling it what to do. You're just saying, here's another example, here's another example. Those examples have to tell the whole story, and examples never tell the whole story. So one of the things that I push for, and if anybody's interested, I'm signing copies of my book, and you can buy my book. But in my book, I talk specifically about the idea of, we're doing this wrong. We need to be able to interface with computers in a way that lets us use examples and reinforcement learning ideas and programming and this sort of inverse programming that you get in the fourth box, because that's what people do when we're trying to convey things accurately to each other. That's what Ashley Lemon did in her tiny little video. She hit all those things because you don't want to just give one thing. It's too easy to misinterpret that. And so I'm a big fan of, we should be changing how we interface with machines, how we tell them what to do. Just that interface doesn't exist yet.
Some of my background in coding for the last 50 years is I go to work for somebody and he assigns me a job to do this thing. And he says, I want you to build 6 subroutines. Subroutine 1 will do this, blah, 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 blah. Using precision numbers to third decimal point, you know, and he gives a good enough description that I can't screw it up by adding a feature that he didn't ask for. And it's small. And then I do another app, and then do another app, and do that. Now I got 18 apps now. Now he says, now combine all these apps together to create this other thing. Those apps are already predefined and checked out and compiled and verified that they function. And now when I write using those tools, they work. This thing spit out a program, but he didn't run it through the compiler. He didn't check for errors. If you're going to do programming, really, you need to include the compiler, you need to include the error checking and go back and rework the program and recorrect to address the input request. And if the input request is on like a chart, fill in the blanks with all the stuff, you might not have missed whether you wanted integers or fractions and other features that would be visited with the pre-thought when you make your request. So when it's come through, it doesn't have the freedom to give features that you didn't ask for.
Yeah, excellent point. So
Because that's the way the engineers.
Exactly, yeah.
As an engineer, I was assigned this job.
Right.
And I wasn't given the freedom.
Right.
To do expressive stuff.
Yeah.
And,
So part of it is you were smart and didn't infer things that weren't said. But part of it is the whole requirements process,
I
right?
did infer what was said, not said. And then usually.
But correctly.
Come back to haunt me.
Oh, I see.
You know, because I would say, okay, just make some, user messages like you did this program wrong or this. Well, I got a little snarky and they didn't like the snarky content. The coding was fine.
Okay.
It was the content that they weren't too thrilled.
Gotcha.
But they didn't specify the error messages.
So you got to write them. There you go. All right.
And I like to have a little humor in the computer, so snarkiness was a nice humor. But
All right. So let me see if I can summarize that back out. So when human beings ask other human beings to write code, there are processes that have been worked out kind of gradually over the years that try to produce the best possible code. Even that, these systems fail sometimes, but nonetheless, they involve requirements engineering, actually specifying this is what I want, saying it as clearly and crisply as possible. Requirements engineering edges right up to programming in a sense, right? Because you're specifying it at such a level of detail that it almost is code. But not quite, right? And then we still need human beings to kind of do that last step and actually turn it into something that runs and is verifiable and so forth. And the notion that we're going to be able to turn this stuff over to the computers without a really careful requirements engineering process is laughable, right? Because not only, it's like human beings aren't going to do that, right? They're going to write their snarky error messages when you didn't want them to. These programs are going to do things that are just like and off track as well. And there's nothing particularly holding them to, even if you gave them requirements to do that, because they're just kind of riffing. And so, yeah, it's a really great point. Yeah.
We have like 60 years of trying to tell humans how to write programs. We have like 3. Asking computers to write.
Right, I think we should expect there to be developments along these lines, right? That people are gonna discover, oh, if you actually want to make your group more efficient and effective and correct, it's not easy, right? One of the things I like to say is if the problem that you're trying to solve is so hard that you need AI to help you solve it, then it's probably hard enough that you can't just solve it with AI. You need processes in place, you need training, you need to do the hard work because a lot of these problems are just plain hard. And I think one of the things that really worries me about companies these days is I think they think that they found the magic recipe for making it so that they can just make money with no effort. And the fact is, no, the systems that they're doing are kind of broken and you need a lot of effort to fix those things. So they're still gonna have to do a lot of work. Yeah.
One of the earlier speakers for today talked about the need for the study of anthropology.
Nice.
Reminded me of when we raise children.
Yes.
This is related to the George Washington piece. We don't just describe data to them, but they learn, I'll call it an ethical culture.
Yes.
And my question is, are people working on, I'll call it features of ethical culture to incorporate into these systems, or is that still too far away?
That's something close to that phrase is currently in use. So the notion is, how do we make these systems so that they're kind of ethically grounded or responsible or trustworthy in various ways? And so everybody's kind of making efforts along those lines. But you hinted at a thing that I think is actually the right answer that I haven't heard people talking about, which is we need to raise them the way that we raise kids. We need to take them through these sort of, you're thinking no, I'm thinking yes, that there's a developmental process that human beings go through, partly because it's maturation and we don't know how to get all the information and you can't train on a trillion tokens of input all at once because people, but nonetheless, I think there's something incredibly valuable about getting somebody to a certain level of maturity and seeing that they're doing that in a responsible way before advancing them to the next stage. And it's going to be more expensive, it's going to be more slow, but I think the thing that we get out at the end is going to be more aligned with the way that we expect behavior to happen. And so that's something I'm thinking about. All right, okay, I'll let you respond.
Wait, it's impossible. It's impossible because half of us think one way, the other half of us, as I mean, humans on Earth.
I completely disagree. I think we all agree on everything.
Think the opposite.
See, he agrees with me, so we're right.
It's possible.
Yeah, so right, so, but this is true with people too, right? So we're gonna raise, my wife is here, we raised our kids, we're pretty happy with the way they came out, you might not be so happy with them. But maybe that's okay too, we can train on multiple AI systems. I don't think there should be the one AI system that is the right AI system for everything. I also think that people are trained to do specific jobs and that these AI systems need to be trained to do those jobs and not necessarily other jobs, right? We're training it to be a radiologist, we don't want it to be a good auto mechanic at the same time. If those things are gonna interfere, I think they're always gonna interfere. All right, I did see some other hands pop up and I wanted to make sure.
Do you have any ways of making sure that students who hand in work to you?
Yes. Do not. So, okay, so the question is, now that we've got these large language models, they are the world's best cheaters that have ever been created. They're just fantastic. And so I teach an online reinforcement learning class where like I created essentially a textbook, a video series for learning reinforcement learning. And I had a bunch of homework assignments. One of the TAs that are running the class at Georgia Tech, they typed all my homework assignments into ChatGPT and it gave 100% correct answers. All my homework assignments are basically solvable just by typing in the assignment and it'll actually write the code for me. That seems bad. I don't have a good answer to that, right? So I did read an article out of Stanford that said the amount of cheating that we're getting today is really not greater than what was around 5 years ago. And I was like, oh, that seems like good news. And then this was how it was reported in the New York Times. It's like, cheating hasn't gone up. Then I went to the actual article. And what the article said is, yeah, it used to be that people were cheating at about 80%. And now they're still cheating at about 80%. And I'm thinking, that's not good news. I think the cheaters are doing better now, but maybe there's not more than because 20% of people would never cheat because they're just super moral or whatever, or maybe they don't understand the instructions, or maybe they're lying in the surveys. But like, we're not gonna get it much higher than 80%. Sorry, all right, so.
I had one.
All right, go ahead.
I had, when I was in college, we had a really hard class and like 80% of the class got really bad scores on an exam. 20% of the class got really good scores on the exam. The reason was the professor was using an exact copy of an exam he gave 4 years ago that these people pulled from the fraternity bias.
Sure. Sure. All right, the very bad.
Oh,
I have a
Then we'll
question,
come forward.
much deeper problem.
Much deeper problem. All right.
Take a simple thing, life was in its worst view.
All right. Just slow there's that form of the line.
When we take the y and feed it back into the x, we now have a closed loop system.
Yes.
Closed loop systems have a nasty habit.
Being chaotic.
Farms you did this, it'll approach the strange attractor.
Yeah.
And then all of a sudden, for no reason, go off somewhere else.
Yep.
And that means to me, AI may be good for all this subjective stuff. But if I've got to determine, for example, thermonuclear war, I can't trust that system.
You have to ask Whopper.
Correct.
That's a, okay, it's a war game reference. All right, so, yeah, so it's really interesting that you said that, right? Because I think 5 years ago, people would have said, well, computers are really good at getting the right answer, but the subjective stuff is never going to work out. And now it sort of has flipped around. There are methods that are actually extremely good. Well, chaos is chaos, right? There's no way to tame that. But to the extent that we're actually talking about systems where there is a reasonable answer, we can build computer programs that can do symbolic reasoning, that can do that kind of processing, but the chatbots are not that.
But is there a system that have, or is there research going on in make these systems reliable? Making them work is one thing, making them reliable seems to be.
Right, no, so what's really interesting is that there's these two different worlds, right? There's the world that we can write some programs that can process symbolic information and get correct answers, but they're not super flexible and that you can't really chat with them. And then there's these things that we can chat with that all shoot from the hip and they'll do fake symbolic processing, but it'll actually be wrong. The notion of a neurosymbolic system, some people are focused on, where that it has elements of both of those combined, hasn't really taken off yet, but this is something that people are absolutely interested in. They recognize the problem that you're describing, and we just don't have a way to fix it yet. All right, yeah, go ahead, sorry.
You said something about the teacher problem, is why not just turn it on its ear and make ChatGPT the main part of the assignment to the students that are gonna be using it? Use this, find what it can produce, and then you correct it and find the errors that it generates and make them work. But now they can't cheat because.
Yeah, so there are a lot, right, so there's a lot of different things that people are doing now to try to, let's work with them instead of against them. And so assuming that they're gonna use it and designing assignments. So
My professor 50 years ago, when HP came out with little calculator.
Yes.
Engineering calculator, $550, the tuition was only $250. Now, can you imagine a calculator coming out now for twice the tuition? Anyway, they came out with it and he said, do we use calculators in that class or do we use the slide rule? What do we want? And he says, I'm going to show you an example. Example 1 is with a slide rule. Example 2 is with a calculator. 3 people own calculators, 47 owned slide rules, no calculators. 100% voted for calculator problems. 3 plus 4 times 7 divided by 5. I don't even need that slide rule. Man, the 3 last ones turned in were the ones with the calculators. Everybody else turned in their exam much faster. And we love that teacher.
So, right, so in general, we have to find ways to work within this technology boundary. We can't give the kinds of assignments to say, hey, write an essay about this thing, where the system could just easily do it. We have to find ways to making sure that the students actually learn what we need them to learn. But I think a lot of people are making efforts along those lines. Hopefully these ideas, we'll find some good ideas and we'll spread them, and that'll be really helpful. Yeah, go ahead.
Yes, thank you for the presentation. I had a very interesting talk earlier from how protecting artists would be very crucial with AI. I'm curious how there could be ways to not only learn from machine learning, but also to ensure that there are protections when it comes to artists, but more crucially, other types of creative works that are done from artists and protecting it from generative AI, especially if it's copyrighted.
Yeah, so, okay, so there's a huge concern about the fact that a lot of these models are trained on the creative output of human beings who haven't necessarily given their permission or are being reimbursed for that. And then the systems are to some degree replacing their creative output. Yeah, I think it's really important that society come up with what we think is the fair rules for that. I think a lot of the rules, obviously the rules were written before this was even an option. I think we actually have to figure out what the right rules are. I know a lot of my colleagues are hoping, boy, I hope that we don't limit how we train these models because it's just so amazing what they can do today. My personal feeling is we should limit them. Like we should, if that means that we're slowing down progress in AI, I think by all means, we should slow down progress in AI. We have to figure out a way to do that's actually fair and that works for society. Because it's not going to be the case that we can just train on everything we have now, create systems that are based on that, undermine all creative people, and then if all you cared about was training AI models, this would still be terrible because you're going to put all the people out of work who were already providing input for your system, right? The whole thing, like the whole system just ends at this point if we don't do something about it. So we have to find a way to make sure that we're supporting folks in their livelihood, while at the same time learning how to use these systems in ways that benefit people. Things like Wikipedia. Oh, thank you. All right, sure, I'll accept that. Things like Wikipedia are written by people with express knowledge that it's going to be used in a very free and open way. People who are writing for Wikipedia are not complaining, oh no, the systems are being trained on my text, because they had that, maybe not that specific use case in mind, but they had the idea that this was going to be used in ways that were unintended by them. Language models that are trained up on Wikipedia seem okay. They're not as good as what you can get by training on the whole internet, but at least they're fair, right? And so maybe that means that we're going to have to put a lot of more effort into creating that data set, but then let's do that. Shortcuts, like I'm like, as much as I am a computer scientist and just love automating things away and certain things, you can't shortcut certain things. Like certain things just require effort, and we need to accept that and put in the effort and make it work. Yeah.
So I was in a intro to AI class at my company, given by Accenture, and the Accenture person cited some study, which I don't know and can't cite, but she said that if you use generative AI, if an expert in a field uses generative AI, they become 20% more productive. If a novice in the field uses generative AI, they become 40% less productive. And it goes back to that, you have to be an expert to know, like the editor, you know, you have to be good at the thing so that you can tell when something's wrong. It's great for a first draft, but don't you dare use that in production.
I totally agree so that's if we can find that study, do something to it, because that's a really interesting one. The idea that experts are actually being accelerated by this and novices are being slowed down. And that's the kind of result I would have hoped for, but it's really cool if somebody actually did that. Hopefully that's not the output of a generative AI system that just made it up. Because that happens sometimes, right? Lawyers are like, oh, I don't really have the time to do this research. Oh, look, there's cases that are exactly relevant and completely made up.
That happened.
I know.
Yeah, but even in our exercises, we had to do something about looking at obesity rates in different countries, in different cities, to understand where you would start a clinical trial for an obesity drug. And so different people, we all put in the same things, you know, tell me the cities where you would do an obesity drug trial. And one output said, well, the obesity rate in Philadelphia is 25%. And then the person next to me was like, well, mine said that the obesity rate in Philadelphia was 37%. So like,
Right,
you gotta look it up and make sure it's right.
Right, because remember, the way these things are trained is they're trained to produce text that's kind of like what they've seen. It's not looking up facts and then expressing them in natural language. It's just riffing. It's just I'd like to think of them as improv artists. They're like, yes, and so they're really good. And just like you wouldn't use an improv artist as your research team, you got to be really careful. Yeah.
So just a humorous little thing. This is a tweet I saw a while ago on Peanut Tweeter. If computers use all the information on the internet to reach sentience, Skynet is going to be an effing moron.
Yeah, I worry about that. All right, yeah, go ahead.
Back to what you were saying about needing to be an editor to actually make use of this.
Yes.
One of my small hobbies is I like to make t-shirts for myself. And I.
Your hat's very cool too, man.
And I made.
Like a Pokemon, is that a Pokemon?
No, it's curvy.
Oh,
I made this t-shirt and it took a lot of effort scanning it from original books from the seventies and then cleaning it up in Photoshop and then arranging it, enlarging it and all that. So I was trying to use, Bing's AI, I think, to make some designs. And he gives me something that's like 95% of the way there. And then at the end, I'm faced with the choice. Learn a lot about prompt engineering or learn a lot about Photoshop. I'm 95% of the way there, and that last 5% needs human
work, yeah.
interaction, and that's on the scale, and a lot of people are gonna not realize that at 95%. They're gonna see, oh, that's done. and then
Yeah,
they're
it's
gonna
good,
try
it's good enough, yeah,
Yeah.
yeah, no, you're absolutely right. All right, yeah,
A little bit of different topic, right? So a lot of the LLMs have been trained on a lot of text and picture at a point in time, and
Yes.
they're not correlate to each other, even though the picture might correlate to the text, but they're not correlated. And a lot of our communication is visual.
Yes.
Not just the written. Any thoughts on, what's being done that you're aware of, to actually capture that visual portion to make it more contextual? For example, like a customer service.
yeah. So, I mean, I'm not sure I agree with the premise that I do think these models are being trained on images and text. They seem to be correlated enough. I started using ChatGPT recently. I'm on a Zoom call and somebody puts up a slide and there's like stuff I want on that slide and I want to put it in my text notes, but it's not in text and I can't paste it. So I grab the image, I save it, I go to ChatGPT, I upload the image to ChatGPT and I say, can you tell me what it says in this image? And it goes, sure. And it writes it all out. Now, this is the standard kind of, what is it called? Optical character recognition, right? Which is a standard thing. And I probably maybe had some access to it before, but it's so nice that in ChatGPT, it just, like I didn't even have to think about it. I didn't have to find the magic word. I just said, what does it say? It writes out the text, I can paste it into my document. And so somehow images and text are definitely being integrated in some way. The fact that you can describe a scene and then it can draw something like that scene also indicates that there's some grounding, there's some relationship between images and the outputs of these language models. So,
So in your mind, right, so if you look at communication, right, there are three parts to it, right? It's what we say, right, how we act, and the tone that we use.
okay, what we say, how we act, and the tone that we use.
Exactly, right? So there's a visual component to it, there's a word component of it, and there's the inflection of the tone of the voice.
Okay, all right.
LLMs are being trained on the text,
Just
the
text,
picture,
yeah.
right? It's a point in time which may or may not be correlated to some extent, right?
Yeah.
So where I'm trying to go is, 50% of the communication is essentially more, the tone and the visual. Is there work being done that you're aware of that's actually trying to capture that and actually make it more contextual and
I see.
more how humans interact?
Right, so when we're talking, there's a lot more bandwidth than just the words, right? And if you just look at the words, it can be actually very difficult to know, was that person being sarcastic? Right, that's why everything on the internet seems like it may be sarcastic and it may be serious and I'm not sure which. So, I haven't heard of that particular idea, but the way that people would address it these days is they would take, I don't know, a lot of YouTube videos or something like that, where there is people talking, people expressing things, and the text, and they can be trained on jointly. Whether there's enough, I mean, there's a lot of videos, like whether there's enough that they can train on that they can actually extract that kind of information, I guess is kind of an open problem. I personally think this is all kind of a bit of a dead end, because if we're actually training on, the solution to everything is just more data, richer data, more multimodal data. It's just overwhelming. We don't have the compute, we don't have the storage, we don't have everything that we need to actually do all that calculation. It's so brute force, right? Where it really could be trained up maybe more incrementally, more gradually, so that it can start to pick up on all these different cues. No, I haven't seen anything that can really do that effectively.
Where I was going with that was, right, so we have been trying to use this in a customer service environment, right? So rather than having a human speak to the person, have the computer speak to it, and then of course, at some point in time do a transition. If you were able to use the video data, and I'm sorry for something to it, actually using the visual input.
Yeah.
Camera, plus, imagine how the telehealth can change, right? Or imagine how your teleservices could change because now you're able to capture those.
Yeah, there's definitely been,
And the text. Right?
yeah, some of those components have been studied. So there are research efforts where you can take a video stream with no sound and then try to just basically do lip reading, actually try to get the text out of that. So so you'd think that if you were to do both at the same time, listen to the text maybe without the images, watch the images without the text, and then merge those two sources of information, you'd have a more accurate transcription than either alone. And so I haven't seen that combination happen, but both of the pieces exist. So this is something that could be addressed.
I wonder if we should maybe take one more question. I can see.
Well, we can go upstairs. I don't know how many people we're gonna lose, but upstairs, in front of the banquet, have a microphone already set up. We have some juices up there. There was some food, but I have a feeling the food is probably.
Give you 2 minutes to take a break if you'd like. So, should we take one more question or should we just do one more and then we'll take a break?
Yeah.
I just wanted to mention, one of the things I saw a little while ago that is a pretty fun experiment is asking ChatGPT to explain a meme.
Explain a meme, okay.
More obscure with the memes as you go. As someone who's in his 20s, a lot of the memes I look at online are very obscure. My dad would not be able to discern it from, from static. So, giving it a meme and saying, explain this with full context, gives some really interesting results. And you need to look at the image. It also needs to know the context in which it's in, and you take a image of, say, a character doing a screen grab from a cartoon. Most of the audience that was made for knows the cartoon and knows the context of the cartoon. They know that scene. And then there might be some sort of filter applied. Maybe it's all blurry for some reason, or there's a lot of layers of JPEG compression applied for a joke. And saying, explain this image of very pixelated Charizard from Pokemon, and seeing if it gets it right, and ask, why is this funny?
Right.
And some of them, sometimes it does get it.
Yeah.
It gets it scarily well sometimes.
Okay.
Sometimes it falls apart. So it's a good thing to try every once in a while, see how good is this at layers.
If nothing else, these kinds of difficult tasks serve as a reminder that these systems aren't actually intelligent yet, right? It's some like people who have their PhD in computer science in AI, who are good friends of mine, Justin, has been very taken in by these things, and it's like, no, I think they really are intelligent. It can be very seductive, and so reminding yourself occasionally that, no, part of what makes these things so mysterious is they're trained on more text than any of us has ever seen. And so the idea that we can wrap our heads around that and understand, wait, actually, if you've seen enough text, you've seen this combination of words in that context, and this picture in that context, and this picture in this context, and 11 different versions of that, which none of us have ever experienced. That's what this system is drawing on, and it can look way smarter than it actually is because of that. And so take it with a grain of salt. This is not, we're dealing with a kind of system that's so different from our experiences that it's easy to misattribute what they're doing. But I think we're gonna call it.
Probably a good.